Hello again, guys. Today we're going to be talking about the basic differentiation rules located in Section 2 of Chapter 2 in the calculus textbook. These rules include the constant rule, the power rule, the constant multiple rule, and the sum and difference rules. So let's begin. So first we're going to start out with the constant rule. Which states that if a constant c is a real number, so it's real, then its derivative, so the derivative of that constant c equals 0. And it's always 0. And this can be proven using the definition of a derivative. So if you use the definition of a derivative, make this equal to f prime of x, and we also know that f prime of x is equal to the definition of derivative. The limit as change in x goes to 0 of x, or f of x plus change in x minus f of x all over the change in x. And let's simplify this by substituting in c. And so you get the limit as change in x goes to 0 of c minus c, because if you plug in like a constant number in here, it's just going to be c because it's constant. It doesn't matter if there's a change in x or not. All over x. This is going to be 0, and the limit as change in x goes to 0 of 0 equals 0. And that's how it's proven. So let's look at some examples. The derivative of the function f of x equals 14 would be what? It would be 0. So f prime of x equals 0, as we just learned in the constant rule. And this can also be shown graphically, because if you graph any, so y equals 14, so just make this 7, make this 14. We know that the derivative of a function is the slope. Well, the leading coefficient of it is the slope of the function. So what is the slope of this function, a constant function? It's 0, so therefore the derivative is 0. This next rule is very key in finding the derivative of virtually any polynomial function as far as its exponents go. And it states, it's called the power rule, sorry, and it states that any function x to the n has a derivative of, so f of x equals x to the n, and its derivative is f prime of x equals n times x to the n minus 1. So the n is the coefficient. Sorry, the n becomes the coefficient. The n is originally the exponent in the function. And this is only if n is a rational number. So n cannot be any fraction. And and that'll be explained in a little bit. Let's look at some key examples. So we have f of x equals 6x to the fourth, and using that, f prime of x, we're going to want to find n times x to the n minus 1, so we already know that this is x to the n. So we have n, 4 is n, so we're going to take 4 and put it in the derivative, and take 4 and put it down here, and so 4 minus 1 is 3, so now we have 4 times x times 3, but we forgot something. We forgot the 6 coefficient right here, and you have to always keep that in mind and multiply that. So we have 4 times 6x to the 3, and if you simplify this, it comes out to 24x cubed. Also, we're going to need to find derivatives of functions that look odd, like this rational function of 2 over x to the fifth. So we're going to rewrite this as 2x to the negative 5, which will help us use the power rule to solve it. So we're going to put the negative 5, which is n, down here, and negative 5 minus 1 is negative 6. So simplifying this out, it becomes negative 10 x to the negative 6. And simplifying it further, since we can keep it this way, but if you simplified it further, it would go back to being negative 10 over, it would go back to being rational of negative 10 over x to the 6. So the next rule is the constant multiple rule. And this is different from the constant rule in that this rule is pretty simple because it's an exception to the constant rule, because the multiplication of it, like the derivative of c times a function, is going to equal c times the derivative of that function. And this is different from addition and subtraction, as if c was being added or subtracted to the function, because then you would take the derivative separately instead of together as all one thing. So this rule states that a function with a multiple real leading coefficient, like c, has a derivative of that same coefficient multiplied by the derived function. So basically it's not derived. It's pretty independent of the derivative. And that's it for that one. Last but certainly not least is the sum and difference rule. So the sum and difference rule. And this states that for any f plus g, any functions f plus g or f minus g, and this can also be written like that, but we're leaving out the x's. It's implied. So this always equals the derivative of those functions added together are the derivative of f plus the derivative of f plus the derivative of g, are the derivative of f minus the derivative of g. And this is as long as all the original functions in question are differentiable. And in turn, the derivatives will also be differentiable. And the sum and difference rule works. So let's do you already used this concept during the power rule, but some more examples are going to be essential. So this is the polynomial concept that we did. And let's do a rational one. Negative 3x cubed plus x squared minus 4 over x squared. We're going to rewrite this as negative 3x, because this x cancels out to 1. This cancels out. And this one is going to be rational. So we got negative 3x plus 1 minus 4x to the negative 2. And this is 4 over x squared. And we rewrote it to use the power rule. So using the power rule, we have negative 3 plus 0. And these are all seen as separate functions. This is using the sum and difference rule, because there's a difference right here. So you take the derivative of 1, you get 0, and the derivative of this is 4, which is a coefficient, times negative 2, which is n, times x to the negative 3. Rewrite that. Plus 0 minus 4 times negative 2 times x to the negative 3. So simplifying that, we get, this negative cancels out, we get positive x, 8x to the negative 3. And this doesn't exist anymore, so we get negative 3 plus 8x to the negative 3. And you can simplify that further as negative 3 plus 8 over x cubed. So let's make this last one kind of complicated looking. And the key is to use the sum and difference rule in order to look at all these separately. So we got 4x to the 5th plus 6x to the 4th minus 2x squared plus 3x minus 4. And so we're going to look at this one first. And this becomes, we got n5, the coefficient of 4 times x to the 4th, which is 5 minus 1, 4. And then 6, the coefficient, times 4, which is n, times n minus 1, which is 3. And then we got 2 times 2. 1's the coefficient and 1 is n. And then n minus 1, or 2 minus 1 is 1. So we just have x, and then this one becomes 3 times 1. And then the derivative of 4, a constant, is 0. And we can simplify this out to be 20x to the 4th plus 24x cubed minus 4x plus 3. So guys, if you have any further questions, I'd like you to consult the section 2.2 in your calculus textbook. And anything else, otherwise, talk to the teacher. And that's it. Bye guys, see you next time.